In this segment, we would like to look at list and tuple comprehension. So in other words, we're looking at list comprehension and tuple comprehension. What does that mean? Do you comprehend what is list comprehension? Well, I didn't initially. I was wondering why they call it comprehension. Turns out, I think it doesn't matter. It's just a cool way to uh, squeeze out a bunch of numbers using a for loop within a list. So it is like making the whole list generation process an expression within which there's a for loop. Remember our for loop? Our for loop normally is a control structure that is outside steering or processing the data. So data is like the items being operated upon, and for loop is the big factory that manages the data that is being processed in a loop sequence. In list comprehension, it's sort of turning the intestines and the body inside out, in the sense that we are having a list. So let's look at list comprehension. So variable is going to be assigned this list whose content is not what we type out, but generated by a loop. And it's a for loop in this way. So for variable, which is a dummy variable, you can use any variable except this one on the right hand side. For variable in range, normally that's the way we set it up, so that it will be 0, 1, 2. Yeah. Calculate 10 plus I. Usually this expression, this miniature expression here, involves the variable, so that the data will have the same expression, but different data will be generated from that. So you can put a bracket around it, and that's going to make sure that this is going to stand out as a lone expression. So for I in 0, 1, and 2, calculate 10 plus I. So that will be 10 plus 0, 10 plus 1, 10 plus 2. End up we'll have 10, 11, 2 in a list. Okay, so instead of typing out 10, 11, 12, we could systematically and very efficiently generate them within the list itself without having to write out initialize x to be empty list. Then we do a for loop like this, right? And then we append onto the empty list 10, then 11, then 12. So this three-liner here is fully understandable. It's very clear, and it's our usual way of doing things. But what is very cool about list comprehension is that it is, well, not just one-liner, but it is allowing us to express the fact that data is our main object, right? This data is a list. This list is our main object here. And the content is basically squeezed out like this with a for loop. So in terms of expressive power, this single liner here is very rich in expressive power. It is allowing us to sort of place the list as our foreground instead of this three-liner, because sometimes we do initialize a list to be empty for accumulating values, just like here. Sometimes we initialize a list to capture certain exceptional data, outlier data, then we put it in, or whatever, so we are not always sure that this list here is the main subject. It may be assisting the for loop. It may be doing other things. We are not sure. So we initialize it, we loop through, and then we use X as the outcome of this for loop. That's fine. But in all these three liners, it does seem like for loop, having a loop, is our main purpose, when actually this is telling us list. I'm definitely going to get a list. I'm definitely making sure that X will have the data type list. Isn't it very, very clear here? Yeah, because over here, although I'm simplifying it, because I'm trying to give an equivalent for loop here of this expression using the usual way to write a for loop. Sometimes within the for loop, we may reassign X to be other data values. For example, when there's error or whatnot. But even when there's error, the error will be stored within a list. So we definitely, number one, we are talking about a list content here. Number two, we know the data type of value for X definitely is a list. So that helps, that emphasizes this notion of data having data type list. So I think that's the biggest value add of list comprehension, right? In terms of logic, this part, the three-liner here, can do the same thing. So in terms of logic, there is nothing that we cannot do without list comprehension. So it's kind of a nice convenience add-on feature that Python uniquely offers, not in other languages. But in terms of efficiency, depending on what we do, but usually because this is very centerpiece to Python's offerings, it's very unique. There is optimization done in terms of having an embedded for within, a list. So instead of saying embedded for, we should be using the more official terminology, list comprehension. Yeah. So when we can do that, and this expression here is not too complicated. If it's too lengthy, it might, shadow the for and then bury it somewhere deep down and it becomes not clear. Then actually, personally, I would prefer a for loop to be explicit about it. So it is just an alternative way to express the same logic. It is not to say that you cannot do it in the usual way. All right. So, but do let people know about your intention to let X have a list. That's the main sort of expressive power for list comprehension. Okay, so because list comprehension generates a value, a sort of data value of data type list, anywhere you have a list, and it can be legitimately produced by a list comprehension syntax, you can use list comprehension. So I'll show you what's going on here. What do I mean by that? So let's switch over to our Spider and paste in some codes. So let's run it first and see the result. Now, in line 9 here, we have for I in range 1, 2, 3, 4, right? Because 5 is not included. So we have this list 1, 2, 3, 4. Square them, right? So I raised to the power of 2. So we'll have 1, 2, 3, 4. If we square them, it becomes 1, 4, 6, 9, 16, which is exactly what we have here. Okay. Now, we were saying that anywhere you have a list, you need to have a list, and your list can be easily produced by a for loop, systematically, then go ahead and do that. So suppose we want a list of lists. All right, so look at this. If we don't have this, suppose we just say I plus 0, then it will be the usual form, right? Because the expression can be anything. We just loop I over 1, 2, 3, 4, and then we get that. That's easy.